Hi everybody, my name is Sophie. Welcome to our ATAR Notes January 2024 lecture series. You are here with me today for our Year 12 HSC Standard Maths lecture. I'm super excited to be here with you today. Before we jump into anything content related, I am going to go over a couple of things that are ATAR Notes related, just to kind of remind you or welcome you to who you are with today. So ATAR Notes is a nationwide company that's been around since 2007 that's been offering free resources to students to the extent that we can manage possible, so that students like you can thrive in your studies without having to pay heaps and heaps of money for help. We've offered free lectures just like these ones since 2015, and we currently offer them quarterly, so they're in January, April, July, and September. Hopefully you've maybe seen some of our lectures before, but if not, welcome to your very first lecture. They are very much in line with our mission to provide students with as many free resources as possible, because we know that it can be very expensive to obtain stuff that we can offer to you essentially for free. So if you're interested in taking a look at the other resources that ATAR Notes provides for free, or the other lectures that are on this week, please feel free to head to atarnotes.com/register. So what are the free resources that we offer? We have hundreds, if not thousands, of downloadable study notes. We also have our free lectures where you can learn from previous HSC high achievers. We have our discussions and online Q&A where you can engage with other students and ex-students. We have our videos for engaging online revision, and our newsletters and articles that kind of keep you up to date on things ATAR related, and also are written by us to provide you with study strategy and tips. We also have an ATAR calculator and heaps more on our website. So again, head to atarnotes.com/register to check that out. All right, we also have thousands of study resources via what we call ATAR Notes Plus. You might have been familiar with this via the name Ed Unlimited, but it's now called ATAR Notes Plus. We have AI tutors through our AI answer bot where you can ask questions about our books and content. And we also have over 1,000 study resources that cover all of the HSC topics. And for standard maths, we have the study notes, which there's a book that kind of explains how to answer questions. And then we have the topic test booklet, which is just a booklet full of questions covering all 5 topics. Okay, so as I said, welcome to our HSC Standard Maths lecture. My name is Sophie Gallagher. If you're in the chat, you can call me whatever you want. Sophie. Sophie's fine too. Just not like miss or teacher, because I'm a few years older than you, so we don't need that going around. So this is a pre-recorded lecture with a live chat. So I'm not able to talk to you via the actual lecture recording. It's pre-recorded. The lecture will run for somewhere around 2 hours, usually an hour 45 to hour 50, 2 hours. You can ask me a question by using the chat, and I am active in the chat at this time, so I'll be answering your questions via the chat as well. But I also tend to answer most of the popular questions because I've been doing these lectures. This is my 4th year doing lectures this year, so I'm pretty well seasoned in the kind of 3-4 questions I always get. So I'll definitely answer those at the end of the lecture via the recording, but I'll answer the rest of your questions in the chat as well. I'd also recommend downloading the slides. You can do this at any time. It should be in like the resources section on this video page, and the video will remain available after the lecture. So there won't be any breaks or lengthy pauses, apart from me maybe taking a drink of water. So if you need to skip around or anything, you can do that with the scrubber bar at the bottom of the video. You can also pause it and come back to it when you're ready, or just come back to the video another day, depending on what you need. Okay, so we're going to cover 4 different topics today from 2 of the overarching topics. So we're first going to look at credit cards from financial, and then we'll do annuities from financial. These are definitely 2 topics I get the most questions on as a private tutor from financial. I feel like with income tax and interest and stuff, it's a little bit better, but credit cards and annuities, I get a lot of questions. And then we'll be looking at bearings and radial surveys from measurement, and then rates and ratios from measurement. So we're kind of going to be covering 4 of those trickier topics that a lot of students struggle with as you head into your second term of Year 12. Before we actually move on to any of the content, I'm going to do a bit of a breakdown of the lecture. So I'm going to start by telling you a little bit about me and who I am. And then we're going to talk about how to study for maths and kind of making study manageable, and what you can do to make this next 9 months not torturous. And then we'll go into our 2 content blocks. So we'll do content block 1, which is financial, credit cards and annuities, and then content block 2, which is measurement, so bearings, radial surveys, and then rates and ratios. And then at the end, we'll do kind of wrap up. You can also pop your last minute questions in the chat, and I'll kind of do a little bit of a chat about like my favorite tips and tricks and things that I think are useful for you to know. Okay, so a little bit about me as a tutor. As I said, my name is Sophie, or Soph is also fine. I graduated in 2020 from Bethany College in Hurstville. I had an ATAR of 95.6. In year 12, my final 10 units were English Advanced, Standard Mathematics, Studies of Religion 1, Modern History, History Extension, and Society and Culture. I also did Ancient History in year 11, and I did Extension English until June of year 12, and I picked up History Extension in year 12 because it's only a year 12 subject. So I floated around between, I started on 12, briefly 13, then back down to 11, and then back down to 10 units. So I took my HSC exams with 10 units. Standard Maths was my best subject. I got a band 6. I think it was like a 94. From memory, I got a band 6 in all of my subjects except for History Extension, where I got, it's a 1 unit, so it's an E3, E4, like E1 to E4, sorry. And I got an E3, but I got a 44. So look, I was one off the E4. Stolen Valor, I'll say it was an E4. I am currently studying a Bachelor of Arts, Bachelor of Laws at UNSW. This will be my 4th year of uni. That is insane to say. I can't even explain to you how quickly it's gone. You will be 25 before you know it. I have a beautiful German Shepherd named Luna. I will say that I did call myself like a teacher's pet, but in a cool way, in high school. I put that in there to justify that if like you're one of those students who finds going to school something that you look forward to or that you like, or that you like your teachers, or you find yourself wanting to spend, time at school and putting your effort in, it's not shameful, it's not weird, it's very normal, and I was one of those students. I guarantee I procrastinate more than you. Usually I just say, ask me when I made these slides. For context, I'm finishing my recordings the day that they're due, which is not unusual, and it's not like I'm breaking any rules, but I didn't do it early, let's put it that way. One of my non-academic tips for the HSC is to plan something amazing for afterwards. I went on like the best camping trip ever. And another thing I don't usually say, but I feel like kind of gives some perspective. I graduated in 2020 and I'm going into my 4th year of uni, but I'm still 20 years old. So I'm not like, 26. I haven't been out of school for like 10 years. I am 20 still, so I'm not 21 for another couple of months. So, you're probably 16, 17, potentially almost 18. We are not very far apart in age whatsoever. So I'm trying to say that as like, I still kind of remember what it was like, and I hope that my advice holds some kind of precedent or weight to you. All right, how am I supposed to study for maths? First of all, it's very important that you start kind of now in terms of like longer term study. So you've obviously done 1 term of year 12 already. You've done some content. If you do not have any summary sheets, you don't have any notes, you don't have any flashcards, whatever it is that you think that you use to study, that's something that you kind of need to be working on semi-now / as soon as you're back into school. So I think that if you did 2 or 3 units of maths, like 2 units of maths from the syllabus last term, and you don't have any like notes or any summary sheets, maybe that's something that I would assign myself to get done in the holidays. So something like, for me, I was a summary sheet person, which actually links into this next tip, which is about keeping a rule book. I wrote a summary sheet for each of the 10 chapters. So every time we finish a chapter, I'd do 1 A4 sheet where I showed working out examples and formulas and diagrams. And by the end of the year, I just had 10 sheets, and that was all I needed. Because for maths, you really don't need extensive notes. In fact, extensive notes is just a waste of time, in my opinion. It's not like you need to be writing, like a notebook full of like notes. You don't need that many. You just need to do your work in your maths book and then consolidate the only very important information on a summary sheet or a rule book. So if I'm saying do some of the groundwork early on, that's kind of what I'm referencing. I'm not saying you have to start doing content that your teacher hasn't taught you yet. I'm saying whatever you do have, try and consolidate that before you get back to school. All right, figure out what you need help with and target it. I think that this is such an important skill, is being able to prioritize, right? If you are, studying and you know that you completely understand. So like the example I always give is that I knew that I was pretty much acing simultaneous linear equations, but I could not for the life of me get bearings down. And I remember sitting in the library one day and I was consciously putting effort into revising simultaneous linear equations when I knew that I could not answer a bearing question to save my life. And I knew I was wasting my time and I was jeopardizing my future marks because I was refusing to prioritize the kind of content that I actually needed to be focusing on. So what I'm saying is spend a bit more time on things that you're struggling with, but don't disregard everything else. I think the way that I do this with my private tutoring students is we do something called the traffic light system, where we code all of our units as green for I would nail it if the exam was tomorrow, orange as I need some more practice, and red as I probably would fail the exam if it was this content. So we start with our red topics and then we do our orange topics and then we do our green topics. And we work through all of the content that the student doesn't understand, but in order of what they're struggling with the most. Know that there is always someone you can get help from. So first of all, your teachers are literally being paid to help you. So if you've got great teachers, ask them questions. But students always say, oh, but my teacher sucks. Like, my teacher's not good, which is not for me to judge, but I'm sure that there are some students out there who don't have a great teaching situation. In that case, other teachers at the school, your peers or older students or friends that you know might help. If there are free tutoring services at your school, you may have an older sibling or someone that's gone through that content before you. I think as well, don't underestimate online resources. Like, there's videos and websites and articles and past papers and topic tests and booklets and NESA HSC past papers that will explain to you how to answer questions. And then the paid angle is also like tutoring and buying notes and stuff like that. But there is always somebody who can help you. That's why these lectures are free. Make sure that you study with your friends, brackets, if applicable, close brackets. This is not a tip that everybody needs to take. It is one that I think is helpful and can reap good results, but it's not always the answer. And I say that because I was someone who would like study with friends and really we just like mess around. But sometimes you need to do that. Sometimes you need to book a room in the local library and just stuff around on one of your holiday days, right? Like, you don't need to always be working. But the times that it did really work for me was when I did the HSC, obviously, in the first year of COVID in 2020. And my friends and I would get on FaceTime and sit there quietly and work so that if we wanted to have a little chat, it was like we were sitting together. But we weren't totally physically distracted. We were still in our same places, our rooms and our desks with our books and our pens and our laptops and our screens and whatever it was that we needed, but there was a friend there who could like keep an eye on you and you would keep an eye on them, and you'd go for a snack break together, or maybe you would work together a day and then the plan would be to meet up that night to go for a drive or get some dessert or something like that. So it depends on the way you're doing it, but I do think studying with friends can be super, super beneficial. And even though, like I said, I've been out of school, like I'm 20 now, I've been out of school 3 full years, I still remember what it was like, but I don't remember it like somebody who is going through it, if that makes sense. So the only people who will truly, truly understand exactly what you're going through are the people around you. Your teachers will be empathetic and they do it every year, but they don't fully understand. Sorry, guys. Bit yawny today. I think it's the screen. It always makes me yawn. Your friends are the only ones who will fully understand. Your teachers will empathize, your parents will empathize, hopefully, but your friends will understand because they're also doing it. And so when, teachers are saying, oh, but look, like it's not the end of the world to your friends, and it might feel like it's the end of the world. And so spend the time with them. My biggest thing that I'm proud of from year 12 was that I had a great year. Even though it was like the hardest year, it was also like the best year. And I had so much fun with my friends and I really enjoyed myself. And so it's not, kind of the end of the world if you have a couple wasted study sessions here and there. And my final most important point is to please take care of yourself. It's going to be a pretty intense academic year for you. But if you neglect your physical and mental health, it will take 10 times more of a toll on you than it needs to. In terms of what I did, I at that time was training Brazilian Jiu-Jitsu. So 2 or 3 days a week, I would be down at our local Jiu-Jitsu studio, and I did it with my brothers. So I was basically beating up my brothers, my two younger brothers, a couple times a week. So that was fun, right? Like that gave me something to get my energy out into. There's nothing wrong with pulling a little arm bar on your annoying little brother. And then I also worked as well. I was a kids swimming teacher 2 afternoons a week. That got shut down in 2020 because of COVID, but nonetheless, it was a good outlet at the time. Like, yes, it was stressful, and yes, I wasn't making much money doing it, but it gave me something that wasn't studying, right? And building that into your schedule where essentially 4 or 5 afternoons a week I had something on was good, right? It gave me something to focus on outside of like just studying. Also, it doesn't have to be something like that. It can be going for walks, yoga, going for a swim, going to, the local track and just like running around for a couple hours or whatever it is that, helps you then, because it is true. Like physical health feeds into your mental health so much. Okay, so let's talk about studying. This is kind of my top tips that I personally write up and present every lecture because I find them the most reflective of my experience with year 12 and exactly how I kind of got through it. So firstly, I was really big into breaking my work into manageable chunks and being as realistic about it as possible. There is nothing more demoralizing than failing to finish your to-do list every single day, right? Like every day you finish and there's always like 3 things left on it and you never get everything done. Now that's not necessarily a bad thing and like, oh, okay, I've just got more work to do in the next few days. But it was because I was overriding my to-do list. I was saying, oh, I'll do a full practice paper, like a 3-hour practice paper, and then I'll do like all my maths flashcards. And it's like, well, no, because I'll wake up, like it's the holidays. So let's say I wake up at 9 a.m. And then I'll lounge around. So I probably won't get out of bed till 10. And then I'll go up and make my coffee or whatever it was. And then I'll like be on my phone for an hour. And then it's midday. So like I better have lunch. And then, okay, I've had lunch and I should probably start studying. So let's say I start studying at 2 p.m. Like this is a realistic day for me in high school. All right, so I do my modern paper. Let's say that finishes up about 6 o'clock, give or take. And now I want to do, like I need to mark that. I need to have dinner. So now it's like, maybe 7 o'clock at night, 8:30. Oh, so now I need to do my maths flashcards. And then I've got this big thing on my to-do list I never got to. I still did a 3-hour practice paper that day. Like that's a great achievement. But trying to be realistic when you've got like kids on TikTok who'll do like 6 practice papers in a day, they are the anomalies and they are not the people you need to be worried about. Most people are not like that. I was not like that. Shout out to our HSC Notes TikTok account. Definitely check it out for some videos from Sophia. She's a gun. But I think the thing people get stuck with is that they're so unrealistic about what they can get done. I write to-do lists that say read assessment notification, annotate notification, make assessment document, title essay, and then the next one will be like write 200 words, read 5 articles about, read 5 research papers, things that I know I can tick off that day. So at least something is getting ticked off, and it actually helps you feel less stressed about approaching your work. Force that separation between school and home, like I said. So I had early classes every day at school. I would start at 7:30, 7:40. So I was out of the house by 7 a.m. every morning. And then I would finish school at like 3 or whatever time we would finish. And then 3 afternoons a week, I would come home and then I would have my Brazilian Jiu-Jitsu training from 7 p.m. till like 8:30. And then the other 2 afternoons, I would go to the local pool and I would work from like 3:30 to 6:30. So I was not home like crazy hours. Like I was home maybe after those work days, I'd be home for maybe 12 hours until I went back to school. And then Brazilian Jiu-Jitsu afternoons, I was maybe home for a couple of hours in the arvo and then I would go out and then I'd be back home by like 8:45, 9 o'clock. So I think that forcing separation so that you're not just school, home, school, home, school, home. Maybe your school, local park, home, or school, coffee shop, home, or school, takeaway dinner or going out to the movies or something, home. Like something that prevents you from just going school, home, school, home. Because you'll just get stuck in that like cycle of it blends into one. And if you don't have that like distance, you end up just kind of being in the one environment all the time. So with that said, my next tip: remain social, FaceTime, online movie nights, play photo roulette with your friends. These are my COVID era tips. they still stand. I think they're great fun. And it's definitely great if like you don't have your license or you can't drive or you can't go hang out with your friends every night, right? Like you got to be at home, but you want to hang out with friends. Photo Roulette is an app, by the way, not a game. But I think that the best thing you can do is like A, never do work on Friday nights. Always make that a social time, a family time, a you time, whatever it is. And B, try and remember that this is like your last year of high school. Life changes when you leave. Like it's not the same. I mean, yes, a lot of it is not crazy different, but take the time for what you have. It's hopefully the best year of high school for you. It's the most fun. It's the most growth. So try and enjoy it with your friends and with your group and with your schoolmates as much as you can. Get out for walks, exercise, yoga, meditation. This is so important. It helps reset you. It helps kind of break up the monotony of staring at screens and books and maths equations and whatever it is. So I like to go, I would just like walk my dog, or I like live near a park. So I just like kind of walk around the park and sit with the trees and listen to music. Or if I was like really stressed, yoga and like a little bit of like lying down meditation I found would sometimes really help. Try and be kind to yourself in all aspects. It's okay to be unproductive. You're never going to be perfect all the time. If you don't get anything done all weekend, you're not going to die. Like it is going to be okay. If you didn't get the assessment done, maybe get that done, maybe stay up a little late. But if you didn't get like your assigned practice that you gave yourself done, seriously, the amount of stress you'll put on yourself when you are just a kid who does not need to be stressing themselves to the point of crying, it's really not worth it. It is never too late to start. So I'm someone who often works better at night, right? Like I'll do stuff during the day and then I'll sit down at like 7:30, 8 o'clock at night and I'll be like, okay, I'm ready to start. And I might work till like 11 o'clock that night, midnight. And that's when I work best. As I said earlier, get out of your room. It's so important. If you just stew in your room, because most of us work in our rooms, right, at our desk, you will, it really, really does harm your study and your mental. Take time off. It's so important, whether this be a weekend or an afternoon or, you've got a friend's birthday. Don't bother trying to like schedule in 2 hours of study while you get ready. Just go to your friend's birthday. Please stay away from ATAR calculators. I'm not the biggest fan of them. I think they can be like motivating, I guess, but like for me, they're mostly just stressful. And when I say take time off and like go, like do all the stuff, because I went to year 12 in 2020, I went to maybe like 2 18th birthdays. No one could have birthdays. So don't take them for granted, okay? No one got to have an 18th birthday. Go to the 18th birthdays. Enjoy yourself. For motivation, check out study tubers. My 3 favorite are Unjaded Jade, Ruby Granger, and Eve Cornwell. I would say like go back to like 2017 to 2019 for Unjaded Jade and Ruby Granger when they were in high school. Eve Cornwell was in uni. They still make great videos. I love them all. They're so intelligent and smart and they impart very great advice. Bottom line, you will get through this. It will be over. Your life will move on. You will look back and laugh at how stressed you were sometimes, but it will end and you will get through this. So that is my incredibly thought out and deep 20-year-old wisdom for you. Not that I have much to impart on you, but that is what I do think kind of like reflects my experience. I think it's, I liked getting advice from people who had gone through it because it showed me like in my very like panicky mind that like, okay, I'm going to make it out of this. Like it's not the end of the world. And it really isn't. It does feel like it was a blip. And nobody asks you what your ATAR is, which is disappointing if you want people to ask you. I think that some people have that problem. But yeah, no one asks you. I do not remember the last time someone asked me what my ATAR was. Yeah, no clue. So if you're looking forward to bragging about that, you'll have about 3 days and then no one will care anymore. All right, let's talk about financial maths and credit cards. So this is part of financial that most students struggle with, and I mean most. Like I've never really seen a student who did a couple credit cards questions and was like, easy, done, sold, golden. No one really gets it on the first go unless you're a genius, and if so, I should put you in charge. Okay, so what are credit cards? They are payment cards that allow users to purchase goods and services with the promise that they will pay back the bank, as well as any additional charges. So you may have heard of a credit card payment before, or like obviously I'm sure you've heard of a credit card. Essentially what a credit card is the bank gives you money, right? They say, okay, yeah, there's like, $1,500 on your card, but you pay this amount back each month, right? Like you have to pay back that amount plus any additional charges. It's usually a little bit of interest, maybe certain surcharges on certain days or whatever it is. So you have to pay the bank back. And if you don't, you are in a lot of trouble. So it's not free money. You're paying all the money back plus a little bit. It's just that if you don't have the money on the 5th of March, you can buy a toaster. It's just that you have to have the money by the 30th or 31st of March so you can pay that money back. Some credit cards also have an interest-free period, others do not. So this is why it's super important to read the question properly. It'll be like, oh, this credit card has no interest paid on it from, the 1st to the 5th of every month or whatever it is. But interest on credit cards is usually charged daily. Interest-free periods will be specified in the question, but they're not super common. Okay, so to calculate the amount owed on a certain amount, including interest, we usually 9 times out of 10 are going to use the compound interest formula. So this is on your reference sheet. You've also dealt with this if you've done compound interest. The elements we have, this is the future value. So this is the amount that will be owed or you'll make. It depends on the question. For a credit card question, it's owed. This is the present value. This is how much we are currently have to pay back, and then this is where we're working out fees. So this is the rate. It's usually represented as a percentage, and then we want to convert it to a decimal. And this is the number of time periods. With credit cards questions, it's usually representing the number of days. Okay. So another quick point, sometimes the question will specify like, oh, it's a simple interest, which means that you don't need to be using like a compounding formula like this. But most of the time it's going to be a compound interest formula like future value because present value. But yeah, as I said, if it says, oh, it's simple interest, oh, it's flat rate, then you just use your simple interest, which is, if you've forgotten, I equals PRN. Flat rate is the same as that. Okay, so to calculate the daily interest rate, which will usually be given to you as a rate per annum, you do the rate divided by 365. So let's say, oh, the rate per annum is 12%, right? It looks like that. You would do 12 divided by 365, and that would give you 0.03. Or that's also equal to like, I mean, it's essentially, it'd be like 0.003% or something like that. You just do it as 0.003. Fun fact, if you're interested, this is the calculator I've had since year 7, which I did year 7 in 2015. Yeah. So I've had this calculator for almost 10 years now, and it has no numbers. So if you hear me doing a few more clicks than necessary, it's because I can't see anything and I refuse to buy a new one. Okay, also keep in mind, if the interest rate is given to you as daily, if it says, oh, it's 0.004% daily, if the question looks like that, then this, don't need to do it. Okay, let's look at an example. Howard bought an old radio for $600. If his credit card has no interest-free period and has an interest rate of 9.32% per annum compounded daily, find out how much he would need to pay after 24 days. Okay, that's our formula. Future value equals present value 1 plus RN. This is everything that's important from the question, right? $600, no interest-free period, interest rate of 9.32% per annum, compounded daily, 24 days. So we know that our present value is 600. Our rate is going to be 9.32% divided by 365, and there are 24 days. So with all of that in mind, we would then place that into our formula. So 600, our rate, which is 9.32% over 365, you can just put it in as that fraction. Time period's 24 days. So we have to pay back $603.69. So this 600 is the radio. This $3.96 or 69, sorry, is the interest that we earned in 24 days. That's why it's such a low amount, right? That's why people are like, oh, having a credit card's worth the benefits because you're not paying much interest. Yes, if you just paid for it on a debit card, you would just pay $600, but you'll see that the interest is so low that it's not that consequential. Unless otherwise stated in the question, always give your answer to the nearest cent in financial maths as well. So don't round that up to 70. It looks like the answer was 69. And as well, I think the thing that I always tell students with credit cards is the common sense test. Should the answer be 540? No, because the radio is $600. Should it be $812? No, because how on earth is it $600 for the radio and then $212 for the interest? Common sense. Does the answer that I have received make sense to the question? Apologies for the consistent water breaks. I am very much starting to lose my voice. Okay. How much interest did Howard pay? You should be able to tell from the question. It's just the difference between the future value and the present value. So our future value was $603.69 and our present value was $600. So it was $3.69. Okay, Diana made the following purchases on her credit card. We have a clothing item purchased on November 15th for $78 and a textbook purchased on November 23rd for $32. Diana's credit card has no interest-free period and an interest rate of 12.25% per annum compounded daily, including the date of purchase and the date of payment. If she pays the total amount owing plus all interest on the 30th of November, calculate how much Diana would need to pay. Okay. So, going through this, we need to calculate the future value for each purchase and then the total future value at the end. So we need to do November 15th, then November 23rd, then the 30th of November. So we'll do the first purchase together. We've got the future value equals present value 1 plus RN. So our present value for that clothing item was $78 on the 15th. So we have our rate as well, which was 12.25% compounded daily. We pop that in here. But our number of time periods, the question said including the date of purchase and payment. So we're going to add 1 to the difference of days. So we're going to do 30th, which is the payment date at the end of the month, minus 15th, which is the date of purchase, plus 1, right? Because it's 15th, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That's 16 because you're including. If you include, 20 to 25, that's 6 numbers, not 5. 20, 21, 22, 23, 24, 25. Not the difference, but the number of numbers. So we've got our payment here, $78, and then our interest rate and 16 days is $78.42 owing on that clothing item by the end of the month. So now we're going to find the second purchase. We have the purchase of a textbook on the 23rd. So we have, and it was $32. Okay, so we've got $32. 12.25% over 365. I'll just pretend I did the 1 plus there. And it was on the 23rd to the 30th, so that's going to be 8 days. Pop that into my calculator, 1 plus, and then 12.25% over 365. And it's to 8 days. That's giving me $32 and let's check if that looks right. Um, 12.25% calculated on yes. Yeah, that looks right. Okay, so let me pop. I'm missing a percentage. There we go. All right, so $78.42. The second purchase is going to be $32.08. And so we've got $78.42 plus $32.08 is going to equal $78.42. Hold on. We've got 100 and, oh, that's wrong, 78.42 plus 32.08. 110.50 owing on our entire payment. So as you can see, we broke that up, and then this is how much he needs to pay overall. So we did our 2 installments, our clothing, and then our textbook, and then answer by adding both of those together. Okay, let's look at example 3. Jimmy reviews his credit card statement for the month of June 2018. Jimmy is charged interest at a rate of 18.9% per annum, paid on the fifth day of the following month. There is no interest-free period on Jimmy's credit card. Okay, so we can see we've got 5 different purchases. We've got clothing for $40 on the 1st of June, an electrical good for $79 on the 5th of June, office supplies for $12 on the 11th of June, $33 for dinner on the 23rd of June, and then groceries for $159 on the 29th of June. Using the statement, answer the following questions. Determine the interest Jimmy was charged on his clothing purchase. So we'll do that one first. It is paid on the 5th day of the following month. So he paid for $40 for clothing. The rate is 18.9% per annum. So we do 18.9% divided by 365. And there are, it's the 1st of June to the 5th of July. So there are 30 days in June. So we'll do, including date of purchase, 30 days plus the 1st, 2nd, 3rd, 4th, and 5th. So it should be 35 days. Okay, and so then once we do that, 40 brackets 1 plus 18.9% over 365 to the power of 35. He should owe $40.73 on the clothing purchase. So the interest is actually just 73 cents. Calculate the total cost of purchasing dinner on the 23rd of June. So dinner is going to cost $33. It is 1 plus 18.9% over 365. And we need to count from the 23rd to the 5th of July. 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 1st, 2nd, 3rd, 4th, 5th. So that's 13 days. And the total cost would be, so we'll put that into our calculator. $33.22. $33.22. The total amount of interest Jimmy was charged on his credit card statement. So we now need to work out the interest for all of these payments. So we know that this one was 73 cents. This one was 22 cents. So now we need to do the other 3. So the electrical good is going to be $79, and then our brackets with our 18.9%, 79, yep, 1 plus 18.9% over 365, and then the amount of days, we've got the 5th of June to the 5th of July, so that's going to be 31 days, and that is $80.27, so it would be minus $79 from that, it's $1.27. So $1, round up to $1.28 based on the decimals. Then we've got $12 on the 11th of June. So $12, 1 plus 18.9% over 365. And our days, we may as well just count them. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 1, 2, 3, 4, 5. Okay, so that's 25 days. And that gives us $12.15 or 16 cents, sorry. So that is just 16 cents. And our last one is $159 on the 29th. So 159 brackets 1 plus 18.9% over 365. And our number of days is just the 29th, 30th, 1st, 2nd, 3rd, 4th, 5th. So it's 7 days, and it is 58 cents. So we then just add those 5 numbers together. And that gave me $2.97. So as you can see, again, interest is not a major number. It is not, contributing to someone's bankruptcy or something like that. But it does slowly and very slowly, gradually add up. Okay. Let's have a look at our next question. Ariana is charged compounding interest at the rate of 0.036% every day or per day on outstanding credit card balances. She has $780 outstanding for 24 days. How much interest is she charged? Okay, so she has $780. This is a compound interest formula, remember? So we need to do $780, 1 plus, our rate is 0.036%, and it is for 24 days. So if we pop that into our calculator, it gives us $786.76. So again, we can just do $6.76. Okay, so here's kind of a cheat sheet for days. I'm going to give you a quick chance to quickly read over that, and then I'll explain what it actually means. Okay, so dates in the same month. All you need to do is take the last day minus the first day and add 1 to that. So if it's the 21st of June and the first day was the 3rd of June, then you just do the 21 minus 3 and add 1. So you include the date of purchase and then you get 19 days. If the dates are over a month, you do how many days? So let's say September 18th, the date of payment's October 11, you do 30, which is the number of days in September, minus 18, plus the number of days in October, plus 1. However, as you've seen, I kind of like to count out loud because it just kind of helps me be a bit more certain. Can't do that in an exam, but you could definitely use your fingers. So just do what works for you. I think that the first one is super foolproof. The second one, it kind of helps to just count it out loud or count it with your fingers as well, just to be super certain. Okay, so we're going to have a quick chat about the tips that I think are the most important. Read the questions super carefully. You can get a whole question incorrect just because you wrote down a date improperly, or you counted your days wrong by 1 and you're off by 3 cents or something, or you added the final interest amounts incorrectly. So make sure you're super careful with those final dates and the aspects of the question you have to remember. Or because, you use the yearly interest rate instead of daily. Make sure you double check, is it saying per annum? Also make sure your final answer is to 2 decimal places. This is a money answer, right? You're talking about money. You can't write $780.1 because they'll be like, well, that's not necessarily correct. Is that 10 cents or 1 cent? You need to be as accurate as you can. Don't go over 2 decimal places. Don't go under. Also try to remember some of the terms when you're discussing cards, reading credit card statement, payment period, payment date, interest-free period, refund or payment or whatever it is that you think I might need to know that term. Just have a skim over, remind yourself of the words that come up frequently so that you don't get stumped by something like interest-free period. Alrighty, that is finishing up with credit cards. We're now going to move on to our second financial maths topic, which is annuities. Okay, so what is an annuity? This is something that so many students really struggle to understand, and I find myself explaining a million times a term. Okay, so with simple and compound interest, you are taking an amount of money, you're giving it to a bank. This is the bank. The bank is then either paying a simple amount of interest, which is just the same amount of money every month, or a compound amount of interest, where it goes up because it's being compounded on more and more money each month. An annuity is something different. You take an amount of money and you give it to the bank. Then the bank spits out, or doesn't spit out, but in the bank is now your money plus interest. That's a money symbol. Then you give the bank the same amount of money you gave them at the start. And then the following month, it's your money plus your old money plus more interest. So what you're doing is giving the bank the same amount of money within regular equal contributions. So the interest is compounding at the end of each period on a different and bigger amount of money. So compound interest, you're putting all the money at one go, you put $10,000 in, you get interest on $10,000, right? Annuities, you put in $1,000 in January, $1,000 in February, $1,000 in March. So yes, you're still putting in $10,000, but you're doing it slower. I'll show you how this looks like graphically, or kind of, it would, on a graph, it would look like this. So this is the line for your compound interest, right? It'll slowly and slowly and slowly increase over time like this. An annuity is going to look like this. So you put in this amount of money and there's a bit of interest, and then you put in this amount of money, bit of interest, this amount of money, bit of interest, this amount of money, bit of interest, same amount of money, bit of interest. It's going to continue to increase over time because you're putting in the same amount of money each time, but you're actually also earning interest on it. It's just going to be smaller and then bigger amounts. So with annuities, you can think of it as two separate arms. We have the future value of the annuity and the present value of the annuity. Now, they often ask you questions with these terms, but they don't massively change what you actually have to do with your questions. So the future value of an annuity is the total value of the investment at the end of the specified term. So the question will say something like, what is the future value if I put in $1 every year for 8 years and there's a 4% interest rate? Let's say you put in $1 in the first year. At the end of the second year, you've got interest on that $1. You've put in a new dollar, so now you've got $2.04 of interest. Blah, 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 blah. Keep doing that. By the end of the 8th year, you'll have $9.214, which actually you would knock off the 4. You'd have $9.21. Okay, so to calculate the future value of an annuity, we use something called a table of future value interest factors. So these tables, when used correctly, are actually just so easy to answer questions. Like it's a one-step process. Find your number, times it by the annuity. You will never be asked to calculate the future value of an annuity without a table. We don't have to worry about learning the calculations. They're these, so many letters and numbers. I don't even want to look at that. Never going to learn it. Do not need to know it, just for understanding. Forget you even saw it. Okay, this is what you're actually going to be looking at. The table below shows the future value of an annuity with a contribution of $1. Use the table to calculate the future value of an annuity, which contributes $570 per month for 6 months at 18% compounded annually. Or monthly. So you'll see that we have a table. This is the time period, and this is the interest rate. So to solve these questions, we need to use the right figures. So we're asked to find the future value that is paid at $570 per month for 6 months, compounded 18% per annum, but monthly. So it's not 18% monthly, it's 18% per annum divided by 12 months. So to find the appropriate interest factor, we need to determine the rate of interest, and we do that by taking 18%, dividing it by 12 months, and it's 1.5% per compounding period. So now we can actually complete the question. So with 6 periods at 1.5% per annum, this is actually on the wrong circle, but I'm pretty sure, yeah, there we go. What you would do is if you had divided it by like 2, right? Or you had like your quarterly interest rate, you probably end up with 3%. But no, it's 6 time periods for 1.5% per annum. So your rate is 6.230. So now we can find the future value. It is literally this easy. 570 times 6.230, the future value of our annuity is $3,551.10. It is literally one equation, you guys. You find your value from the table, from the two intersecting lines, your time period, and your interest rate, and you times that by your annuity amount. It's so simple once you understand it. There is no fiddling around and timesing multiple times. It is one equation. Okay. What does this mean? This is including the annuity paid per period, so all 6 $570 installments. So we paid $570 6 times, plus the interest earned. So if the question said, hey, but what was the interest earned on the annuity, right? Not the actual total value of the annuity, you would find this future value. Then you would find how much was actually your money originally, which was 570 times 6, so $3,420, and you would subtract that from the amount that you actually have earned, $3,551.10. So the annuity itself is mostly your money, but the bank has paid you $131.10. Okay, we're now going to take a look at some more questions. Using the future table below, determine the future value of an annuity of $2,500 per quarter at 16% per annum compounded quarterly for 1 year. Okay, so we have 16% per annum compounded quarterly. So 16% divided by 4 is going to be 4%. So we have our 4% interest rate, and it's quarterly for 1 year, which is 4 times in the year. So 4.2465, and our annuity is 2,500. So 2,500 times 4.2465 is going to give us $10,616.25. So let's say we were actually asked, oh, what's the interest? We'd have to subtract our annuity that we paid. So 2,500 times 4 is 10,000. So we would subtract 10,000. So the actual interest that we've earned is $616.25. Okay, question 2. Abby is saving to purchase a cello. She deposits $1,050 into an account at the end of each year for 4 years. The account pays interest of 8% per annum compounding annually. Use the table to calculate the value of Abby's investment at the end of 4 years and the interest Abby earns on her investment over the 4 years. Okay, so we've got $1,050. It's 8% per annum compounding annually, which means we don't actually have to do anything to our numbers, right? 8%, 4 years. Our rate is 4.5061. We need to times that by 1,050. 4.5061 times 1,050 equals 4,731 and 41 cents. So the value of the investment at the end of 4 years is $4,731.41. The interest earned on the investment, we need to find out what is Abby's money originally. So 1,050 times 4 is $4,200. And we need to subtract that from 4,731.41 minus 4,200. And that would give us $531.41. Like so. Okay, using the table provided, determine the present value of an annuity if $8,000 is contributed annually for 3 years at 12% per annum. Okay, so it is annually, again, 12% per annum for 3 years. Our rate is 2.40, so it's simply 8,000 times 2.40 19,200. So I want to highlight two things about this question. Number one, it says present value, right? So it's actually the same thing, despite the fact it doesn't say future value. The second thing is that $8,000 contributed annually for 3 years should be $24,000. Yet our answer is $19,200. Now, this is a fault of the question. This is not a fault of us, right? This question is designed to not really make sense, right? Like, how do you put it in 3 times, but you end up with less money than you started? 19,200. So don't worry too much if you're pretty certain the question is just kind of written poorly. Our answer is still correct. Okay. A table of future value interest factors for an annuity of $1 is shown. An annuity involves contributions of $12,000 per annum, which is per year, for 5 years. The interest rate is 4% per annum compounded annually. Our first question is to calculate the future value of this annuity. Okay, so it's 5 years annually, and the interest rate is 4%. So our rate from our table is 5.4163. And we're going to times that by 12,000. So 5.4163 times 12,000. And that gives us an answer of $64,995.60. Calculate the interest earned on this annuity. We need to find the amount that we contributed. So 12,000 times 5, and that should give us 60,000. Yeah. And so all we have to do is subtract that from our previous answer. $64,995.60 minus 60,000 is going to give us $4,995.60 worth of interest. Okay, here's our final question for annuities. Calculate the present value of an annuity that would provide a future value of $25,000 after 4 years at 6% per annum compounded annually. Okay, so we've got a $25,000 at 4 years, 6% annually, 6%, 4 years, 3.47. So we would do 25,000 times that's poorly written. This is a bit of a different question. We're asking to provide the future value of $25,000. So what we actually do here is do 25,000 divided by 3.47. And we get $7,204.61. So this is the amount that we need to contribute every year for 4 years to get $25,000 at 6% per annum compounded annually. So if you're asked, how do you find this future value using, like, what would the present amount need to be? That's when you divide by the rate, not times. Okay, how do you ace annuities? Draw all over your annuity table. Make sure that you're using, if it's a really big table, use like a ruler or like dotted lines to make sure that you're choosing the right intersecting value. Like it says there, use a ruler to make sure you're using the right number. You don't want to just choose the wrong value from the table and then like get the entire question wrong. Take your time working out the number of periods and rates. If you're changing the time period, you're more than likely changing the rate and vice versa. Always double check them both. If you're doing something to one, you're probably doing something to the other one as well. Okay, we're now going to move on to content block 2. We're about an hour through our lecture, so we've got about 45 minutes or so to go. All right, measurement, bearings and radial surveys. So bearings are the direction of one object from another. So there are 2 types of bearings. There are compass bearings and true bearings. So compass bearings are these ones that you can see on your phone. You have a phone compass, you can point it. That is telling me that is exact north right there. So you've got a compass bearing, and then we've got true bearings. These are not bearings that you see on your phone. Compass bearings use the 4 directions of the compass, so north, east, south, and west. And they also use northeast, southeast, southwest, and northwest. They're indicated by those red dotted lines. Okay, so when you're using compass bearings, you will either state an angle as being north or south, and then it's either going to be the number of degrees towards east or west. So when you're doing it, you're only ever working from north towards east or south towards east, or then north towards west or south towards west. You never work from west to south or from east to north. You're always working either it's north or south, and then you're going into either east or west. All right, so what are each of these angles using compass bearings? How would we work these out? Well, this one here, this pink line, is going to be definitely north, and it looks like it is, if that is 30 degrees, that this must be 60 degrees away from the east. So it'll be north, 60 degrees east, and then this line is definitely south, and it is, for this one we would do 30 degrees because it's 30 degrees away from east. And then this one is going to be, 60. I take that all back. Why do I keep second guessing myself? This one is 24 degrees away from the south line. So we would do 24 degrees west. We've got those there. North 60 east and south 24 west. Remember, you're always using the angle between the vertical line, so don't worry about using this angle in here. All right, we're now going to take a look at some more examples together. Amanda hiked 67 kilometers from her car on a bearing of south 64 east. How far did she travel due east to the nearest kilometer? Okay, she traveled south 64 east, which is in this direction. So this is her car. We'll draw Amanda's little car. There's her little car. We'll give it a little A. And she traveled 67 kilometers on a bearing of south 64 east. So we'll draw a compass. This is south. This is east. And we know she went 48 degrees, so just over 45 degrees that way. So this must be 48 degrees. She traveled that direction. And we know this is a 67 kilometer line. How far did she travel due east to the nearest kilometer? So this is actually a trigonometry question. What we need to do is draw a triangle. This is 90 degrees. This is 48, which we know that all the angles of a triangle add up to 180 internally. So we do 180 minus 90 minus 48. This other angle is going to be 42. And we know that this is 67 kilometers. So we know that this is the due east line that we're looking for, right? So this is our kind of like piece of information that we're searching for. Let me just try and grab, there we go. All right, so that's the question that we're looking for here. Let's see, do I have a better diagram? No. Okay, so what we'll do is, now that we know that, we really just need to use one of our sin, cos, or tan ratios to work it out. So this is our hypotenuse, this is our opposite, and this is our adjacent. And we're looking for our adjacent, and we have our hypotenuse, so we can use cos. So our angle cos is going to be cos 90, and it's going to be our adjacent, which is our x, over our hypotenuse. So we'll have a look. Cos 90 times 67. Oh, hang on. No, that's incorrect. I used the wrong angle. Where is our angle? 48 is our opposite angle. Take it back. Cos 48. Actually, I should just have this on my slides. There we go. Cos 48 times 67. And we're going to get 44.83, which is equal to 45 kilometers. So again, it was here. This angle here is opposite this, and this is opposite that. Sorry, not our 90, our 48. And that gives us 45 kilometers. So the thing with bearings is it often turns into a trig ratio question, even though it started as one length and one distance, right? Like there wasn't even, the angle is like buried in the bearing, right? Like it's not even, doesn't even look like a trig question to someone who's used to very like normal trig questions. So that's why it's important to try and understand the connections that each of your topics have with one another, because this is a question where it's like, oh, yes, I'm doing a bearings question, but I need to bring back my trig knowledge, which luckily we teach this with trig. Okay, so let's have a look at true bearings. True bearings measure the size of the angle clockwise from north. So they're always 3 digits. For example, we've got this one, which is south 14 west as a compass bearing. But as a true bearing, it's 194 degrees T, or true, because this is 180 plus 14. So 180 plus 14 is equal to 194 degrees true. So you always add the T at the end, and there's no direction, no north, south, east, west. We'll have a look at these two. So this one would just be, you always do 3 digits, 23 degrees true, like that. And this one would be 90 plus, this is 47, which means that this must be 43. Yeah, that must be 43. So 90 plus 43 is 133 degrees true. Okay, this is from the 2014 HSC General 2 paper. The following information is given about the locations of 3 towns, X, Y, and Z. X is due east of Z. X is on a bearing of 145 degrees from Y, and Y is on a bearing of 60 degrees from Z. Which diagram best represents this information? So let's start by ticking off each of our pieces of information. X is due east of Z means that it must go ZX. So we know that this and this are not correct. X is on a bearing of 145 degrees from Y means that this angle must be 145 degrees. So let's see. Either of those could be 145. Now we could work it out from there, but let's actually go to our last piece of information just to confirm. Y is on a bearing of 60 degrees from Z. This is Y. Z, we've got, okay, 60 degrees, 60 degrees. So we have to work it out from this piece of information. Now, if X is on a bearing of 145 degrees from Y, it means that this angle has to be 145. Now, if this one's 145 and this one is 120 because it's the internal opposite to 60, making out 180, it cannot be A. So therefore, C has to be our answer. Okay, here's another example. A ship sails 6 kilometers from A to B on a bearing of 121 degrees. It then sails 9 kilometers to C. The size of angle ABC is 114 degrees. What is the bearing of C from B? Okay, so we've got A, B, and C. We've been told the ship sails 6 kilometers from A to B. So we would label this 6 kilometers. And it's on a bearing of 121 degrees. So this angle here is going to be on a bearing of 121. Yeah, that's 121 degrees. It then sails 9 kilometers to C. Angle ABC is 114 degrees. Okay, so that's 114 degrees. What is the bearing of C from B? So we're looking at C from B, which means we need this angle. So we know that if this is 121, these are both north lines, which means we can find out this angle here by doing 180 minus 121. So it's 59 degrees in here. So if we do 114 minus 59 degrees, we get 55 degrees. So this side must be 55 degrees, which means the bearing of C from B is 55 degrees. Find the distance AC, so we're looking for this line. We can do our cosine rule here. So C squared is equal to A squared. So C squared plus B squared minus 2 times A times B times cos C, which is 114. So once we pop that into our calculator, 6 squared, 6 squared plus 9 squared minus 2 times 6 times 9 times cos 114. We get 160.92, and it says to the nearest kilometer, so 161 kilometers. That is a kind of more complicated bearing and radial survey question. Okay. So, how to ace bearings. Lots of people struggle with this topic. You're not alone if you think it's that hard. Please keep practicing. Remember that true bearings always need 3 digits as well. So if the number is lower than 100, you always put a 0 in front of it. So don't do like 62 true. You got to do 062 true. Okay, and then also remember the order of compass bearings. You're doing north, south first, and then east and west. So that's bearings. We're now going to move on to radial surveys. These involve measuring angles from a center point. So specifically, you'll focus on compass radial surveys. They give you a bunch of true bearings. That's why it's super important that before you kind of tackle radial surveys, you're also comfortable with bearings. Okay, so this is a standard question. Find the size of angle APB. So you'll see we have a center point here, which is represented by the letter P. Then we have the distance to those outer points. You could even think of them as like, this is the solar system. Like this is the sun and these are all the different planets. And then you'll see we've got true bearings. So this one is 53 degrees true, 95 degrees true, so on and so forth. Find the size of angle APB is this angle. This is super simple. All we need to do is find the difference between these two angles. Now remember, this is 0 degrees here. So it's going to be the difference between 360 and 308 plus 53 degrees. So 360 minus 308 is 52 degrees. Plus 53 degrees on this side. So our final answer is going to be 105 degrees for angle APB. Okay, find the length of CD. So we're going to do this using the cosine rule. So we've got CD here. I like to draw out my own triangle because it gets a little complicated. Okay, so this one is 59 meters on this side, 42 meters on this side. We know that this angle internally must be the difference between 162 and 95. So 162 minus 95 is 67 degrees. So what we're going to want to do is find, well, the area of the triangle is half times A times B times sine C. So we can do that by using what we have here. We'll do half, we're not looking for the area, I'm reading ahead. We're looking for the length of CD. So we can just use the cosine rule. So we've got, this is going to be our, like C we'll call it. And to find an opposite side, we can do C squared equals A squared plus B squared. Sorry, we're going to jump down a line. Minus 2 times A times B times cos C, so 67. Pop all that in a calculator. And that gives me the answer, because we have to square root all of that, 57.51. Okay, so 57.51 is this direction. And actually that reminds me, back on this question, I didn't square root it. So you actually have to square root that. I take back my 161 and it's actually 12.68 nearest kilometer. So 13 kilometers. My brain's fuzzy, forgive me. Okay, there we go. The area of triangle, okay, so yeah, we've got that 2, square root, what did I write down? 57.51, okay, it's round to 52. And then the area of triangle APE, so we've got this triangle, where is it? APE, we have to do half times A times B times sine C. So half times A, which is 61, times B, which is 52, times sine 69. And that'll give us the answer 1,480.66 meters squared. A lot of writing on that slide. I'm going to give you, hold on, I'll just erase all that ink and you can see those answers a little clearer now. There you go. Okay, let's have a look at another radial survey question. This diagram shows an incomplete radial survey of a block of land. Find the size of angle AOB. So AOB is this angle in here. And we can see we have 180 minus 50. So all we have to do is 180 minus 50 is equal to 130 degrees. Calculate the length of AC. Again, we have our two internal sides and our internal angle is going to be 30 plus 50. So that's going to be 80 degrees in there. And it's again the cosine rule. So C squared is going to be 375 squared plus 225 squared minus 2 plus 375 plus 225 minus 2, wait, A squared plus B squared minus 2AB, now I'm forgetting my rule, hold on. Yeah, times, not plus. Times, and then times cos 80. And once we do all of that, and square root it this time, square root, we get 402.426. So we'll do 402.43 meters for this side. Okay, here is another example. Refer to the radial survey below, find the angle EOA, find the length EA, and find the triangle EOA. Okay. Angle EOA is just going to be the difference between these two. So 334 up to 360. So 360 minus 334 is going to be 26. And then we got to do plus 38. So that internal angle is going to be 64 degrees for this one. The length of line EA, again, we do our cosine rule. So it's going to be A squared plus B squared. Minus 2 times A times B times cos C. So pop all of that in. Make sure you square root. Now answer should be 6.36. 6.36 centimeters. Find the area of triangle EOA. So it's going to be half times A times B times sine C. Remember, you need a group of information like this all on one side. And we can pop that in our calculator. Half. Oh my gosh, what's happening? Half times A times B times sine C. And that gives me 12.58 centimeters squared, like that. Okay, let's have a look at this example here too. Imagine that each side of the radial survey is connected to create the shape JKLM. Find the perimeter of the shape. So this involves us doing essentially 4 applications of the cosine rule to find the perimeter of this shape. And then we want to find the area. So this one's quite lengthy. To find let's kind of treat it as one big question. First, you find all the internal angles. So 360 minus 324 is 36 plus 27 is 63. So this one's 63 internally. This one is 148 minus 27. So that's going to be 121. This one's 237 minus 148, and that's going to be 89 degrees on all of these. And then the last one is 324 minus 237, and that's going to be 87 degrees, like that. So then we need to do the cosine rule to find each of these larger lines. So the first one is going to be 12 squared plus 11.78 squared minus 2 times 12 times 11.78 times cos 63. And that, once square rooted, is going to be 12.43 kilometers. The next one, again, same thing. So 11.78 squared plus 11 squared minus 2 times A, which is 11.78, times B, 11 times cos 121, square root it. This one's going to be 19.83 kilometers. The next one, so 11 squared plus 13.24 squared minus 2 times 11 times 13.24 times cos 89. And that's going to give us, once square rooted, 17.06 kilometers. And the last one, 13.24 squared plus 12 squared minus 2 times 13.4 times 12 times cos 87, square root it, and that's going to give us 0.40 kilometers. And so then we find the perimeter by adding all those together. So 17.40 plus 12.43 plus 19.83 plus 17.06 gives me 66.717. So we would do 66.72 kilometers. And then to find the area of the shape, we need to find the area of all the triangles. So the first one is going to be half times 12, so half times AB sine C. So half times 12 times 11.78 times sine 63. So the first triangle is, we'll list them out here, 62.98 kilometers squared. The second one is half times 11.78 times 11 times sine 121. So the second one is 55.54 kilometers squared. The next one is going to be half times 11 times 13.24 times cos 89. And that's going to be, not cos, hold on. Oh, okay, let's restart. Half times 11 times 13.24 times sine 89. And that is 72.81. And the final one is half times 13.24 times 12 times sine 87. And that is 79.33 kilometers squared. So we add all those together. And we get 270.66 kilometers squared. Oh, take a breath. That is how complicated these questions get. It's just doing the same thing over and over and over and over and over, and then potentially over again. Okay. This is our very last question, although no, we will not be doing this because it is that long, but do come back to it. It's just that we have one more topic to get to and we only have, how long left? 30 minutes. So I don't want to do this question and the other topic and the wrap up. Very much come back to this question on your own though. But how do you ace radial surveys? Remember that when you're looking at compass radial surveys, the angle are the positioning on the compass, not the angle, the size of one of those angles. So on this one, right, like this is not a 37-degree line. It's the difference between these two. Remember that degrees start from north and not from a prior line. They're always going north around. And radial survey questions are not easy. They take a lot of time. So please just keep attempting and trying and labeling your information and practicing. All right, our last piece of content is rates and ratios. So these are what we use to compare, or rates, sorry, are what we use to compare one form of measurement to another. So something like kilometers per hour, dollars per kilo, people per class, something like that. So often a question will be like, convert this rate to another or use this rate to solve a problem. So we're going to look at both today. So to solve a question involving rates, you do need to kind of understand all of the different kinds of measurement. Now we looked at, you'll look at these like obviously in your practicalities of measurement in year 11, but they're easy to forget. So make sure you draw out some kind of conversion table that you have easily accessible. Mine was on a reference sheet that I drew for myself, and I would always come back to it until I felt like they were ingrained in my head. How this works is essentially, I want to convert something from millimeters to centimeters. I follow the line. Okay, I need to divide my number by 10. All right, so complete each of the following: 50 meters to centimeters. Well, meters to centimeters is timesing by 100. So 50 times 100 is 5,000. Like that. 4,800 meters to kilometers. Meters to kilometers, we divide by 1,000. So 4,800 divided by 1,000 is going to be 4.8. Kilograms to tons is going to be divided by 1,000. So 9,750 divided by 1,000 is 9.75. And kilograms to grams is going to be times by 1,000. So 3.2 kilograms times by 1,000 is 3,200 grams. Okay, and you'll see our answers here as well. Same ones. All right, let's have a look at this 2018 HSC General 2 paper question. The driving distance from Alex's home to his work is 20 kilometers. He drives to and from work 5 times each week. His car uses fuel at the rate of 8 liters per 100 kilometers. How much fuel does he use driving to and from work each week? He drives to and from work 5 times a week. It's 20 kilometers to work and then 20 kilometers home. So he's doing 40 kilometers a day, 5 days a week, which means he's doing 200 kilometers each week. Get a job closer to home, Alex, geez. Which means he's doing 16 liters, not 8, because 8 is every 100. There's 200, which means he's doing 16 liters. This is from the 2016 HSC General 2 paper. Calls on a mobile phone plan are charged at the rate of 54 cents per 30 seconds, or part thereof. What is the cost of a call lasting 2 minutes and 15 seconds? Okay, so we then have 54 cents per 30 seconds. So 54, we know that there are 54 times, that looks right. So it says are charged at the rate of 54 cents per 30 seconds or part thereof, which means that even if you go over by 1 second, you're being charged 54 cents for every time you cross over a 30-second boundary. So there are 4 in every 2 minutes, and then this is part of one of them. So we would just do 54 times 5, which is $2.70. Okay, here are some more examples. The price of oranges is $4.25 per kilo. If each orange weighs 150 grams, how many whole oranges could Jenny buy with $2.50? So it's $4.25 per kilo. She has $2.50, and an orange is 150 grams. Which means that if it's $4.25 per kilo, and she has, we want to figure out, I guess, how many oranges she can buy with $2.50, we can find that, let's do $4.25 divided by 10. Oh, actually, no, that's not the best way to do that. I guess the best way to do it would be to find how many oranges are in a kilo. So we've got 1,000 grams divided by 150. So that's 6.6 oranges in a kilo. But she only has $2.50 of that $4.25. So if we divide 6.6 down by $4.25, we find that one orange is approximately $1.55, and she has $2.50, so she could only buy really one whole orange, it's looking like. Is that correct? 6.6 divided by $4.25. Oh no, hang on. $4.25 divided by the 6.6 oranges. No, so an orange should be, this is more accurate. 66 cents. Okay, so she could buy $2.50 divided by 66 cents. Looks like she can buy 3 whole oranges. All right, which is better value for money? 9 slices of garlic bread for $3.20 or 12 slices of garlic bread for $5. We just want to do some simple division. So the first one is $3.20 divided by 9 slices. So one slice is going to be 35 cents. And the second one, we've got $5, but there are 12 slices. So one slice is going to be 41 cents or 42 cents. So the better value is going to be the 9 slices for $3.20. All right, here's another example. A refreshment stand at the market sells its iced tea in 4 different sizes. Showing calculations, find which serving size offers the cheapest iced tea. Okay. Oh, hang on. This one doesn't have, it's missing information. We can't do it. Okay. Bye. Every day, a 1200 watt microwave oven is used for 45 minutes at 40% power. Electricity is charged at 25 cents per kilowatt hour. What is the cost of running this microwave for 180 days? Okay, so it's used at 40% power. So first, let's find what 40% power is. So 1200 watts times 40% is 480 watts. So 480 watts is used for 45 minutes, which means that we then need to divide that by 3/4 because we're not using it for a full hour. So divide that by 3/4. Times that by 75% is the easy way to do that. 75%. So we're using 360 watts of power per day. There are 180 days. So it's 64,800. We're going to divide that by 1,000 to get it down to kilowatt hours. It is 64.8. And we're going to use it, again, it's 25 cents per each. So 25 cents. It's going to be $16.20. However, that's if you're dividing it down. If you're just using it as a 1200 watt per minute, then it would be a much higher answer. So just keep an eye on what the question's actually asking. Okay, here's another question. A laundromat can wash 12 loads of laundry in 1 hour at full capacity. A standard load of laundry weighs 7 kilograms. Here's some information about 2 different washing machines. The top loader uses 10.25 liters per kilogram of laundry, and the front loader uses 6.5 liters of water per kilogram of laundry. So working at full capacity, how many liters of water would the laundromat expect to save in 1 hour by using the front loader instead of the top loader? Okay, so it's doing 12 loads of laundry 1 hour. Standard load is 7 kilograms. So we've got 7 kilogram. We'll have to compare it, each top loader and front loader. So we've got 7 kilos for the first one, 10.5 liters of those kilos, and we're doing 12 loads of laundry. So 7 times 10.25 times 12 is 861 liters. And the second one we're doing is 7 kilos, 6.5 liters, and 12 loads of laundry. and that one's 546 litres. So we're going to find the difference, 861 minus 546. We're going to find a difference of 315 litres expected to save by using the front loader instead of the top loader. Okay, we're now going to move on to ratios. So rates compare things of different measurement, like litres per kilo or dollars per kilo or centimetres per metre or whatever it was. Ratios compare the same form of measurement. So this will be something like length or money or weight or whatever it is. So when simplified, it's important that ratios always whole numbers rather than something like a decimal or a fraction. They don't always need to be to 1. Oh, and when discussing ratios, you also need to really be specific about the order that you provide the measurements in. So the first question says, simplify the following ratios. This first one is 24 centimeters to 32 centimeters. That could be the length of this plant versus this plant. What you want to do is find the highest common factor between those two, right? So the highest number that divides into both 24 and 32 will probably be 4. So 24 divided by 4 is 6. And 32 divided by 4 is 8. Now we can also go down again because these both divide by 2. So we could go 6 divided by 2 is 3. And 8 divided by 2 is 4. So there we go 3 to 4. We can't get any lower than that. Next, we have 3 meters to 80 centimeters. The first thing you want to do is switch one of these to the other measurement. So we're going to go 300 centimeters to 80 centimeters because I don't really want to deal with a 0.8 meters. And now we need to find the lowest common denominator. Again, this is probably going to be 2. So 300, or the highest common, 300 divided by 2 is going to be 150 centimeters. And then, let's do it the other way first. Let's go down by 50 first. So, we can't do that. Let's try 40. That doesn't work. Okay, we'll go down by 20. So 300, we can do 15 centimeters, and this would go down, if we divide 80 by 20, we're going to get 4 centimeters. So 15 centimeters down to 4 centimeters, and we can't really get any lower than that. So it'll be 15 to 4, like that. And remember, you don't reverse the order because the front is now bigger than the back. It has to still represent this exact same ratio. Okay, so yeah, the highest common factor is what we're looking for. The highest number which can be divided exactly into 2 or more numbers. Therefore, 3 to 4, and this one 15 centimeters to 4 centimeters. Okay, here's another practice question. If Jane and Brooke's heights are in the ratio 9 to 10, calculate Brooke's height when Jane is 162 centimeters tall. So this is where I want to introduce you guys to the idea of parts in a ratio. Jane is represented by the number 9, and she is 162 centimeters tall. So 162 divided by 9 means that one part of the ratio is 18 centimeters. And it's always the same across the ratio. So 18 centimeters is one part for the entire ratio, which means that Brooke, which is 10 parts, we just have to times by 18. And we know that Brooke is 180 centimeters tall. So when you're finding the part of the ratio, it's equal whether you're dealing with the front half or the back half. Okay, Rosewood High School has a total of 83 teachers and 1,072 students. Eastwood High School has 46 teachers and 622 students. Which school has the better teacher to student ratio? So Rosewood is 83 to 1072, and East High School is 46 to 622. A really easy way to simplify a ratio is to just type it into a calculator as a fraction and hit equals and see if it goes anywhere. So the first one doesn't go anywhere with that, and my suspicion is the second one actually does decrease. So we can get the second one down to 23 to 311. But what I would really want to do to answer this, it's quite easy, is just divide the larger number, so 1072, the number of students, by the number of teachers, which gives me to every one teacher, I have 12.92 students. Same with this one, 622 divided by 46. For every one teacher, I have 13.52 students, which means that Rosewood has the better teacher to student ratio. The better ratio would be the smallest number of students to the highest number of teachers. Okay, a school is calculating measurements for the new soccer field. The PDHPE head teacher insists that the perimeter of the field be 400 metres for track and field events at the athletics carnival. The soccer coach, however, states that it must have a 3:2 ratio. What measurements would satisfy both people? Okay, so the PDHPE teacher wants the perimeter to be 400 metres. So something like maybe we could do 150, 150, 50, 50. Whatever it is, it has to add to 400. However, soccer coach wants it to be a 3:2 ratio, which means that this side is 3 parts and this side is 2 parts. So what we can do is start by working out half of it. So let's say we've got 5 parts, 3 plus 2, and we've got 200 meters to deal with. So 200 meters divided by 5 means that one part is 40 meters. So that would mean that the first side, which is 3, we do 3 times 40, which is 120. And then 2 times 40, which is 80. And then 120, and then 80. And if we add all of that together, we get 400 meters. So this is a 3:2 ratio. And it's also 400 meters in perimeter. So when you're dealing with the ratio, add both parts together to find the total number of parts and then deal with the half of it so you can expand it just to the whole section. Okay, this is another example. In a 20 kilogram bag of garden fertilizer, 3 components of nitrogen, phosphorus, and potassium are included in a ratio of 2:1:3. The 3 components make up 50% of the bag, as the other 50% is other nutrients. What is the weight of the potassium in the bag? So the ratio is only making up 10 kilos of the bag. And there are 6 parts to the ratio. 2 plus 1 plus 3 is 6 parts. So 10 kilos divided by 6 means that 1 part is equal to 1.67 kilograms. And we know the potassium is making up 3 of those parts. And 1.67 times 3 is going to be 5 kilograms. And it's also half of the ratio. So 5 kilograms of the 20 kilogram bag is potassium. Okay, write the following statements as ratios. This one, we won't write them as simplified. It's just, I guess we can, 30 cupcakes to 330 cookies. Let's see, we could go, this one, we could go 1 to 11 because the highest common factor is 30. 190 centimeters and 145. We could do 38 to 29 is the lowest we can get. 18 laptops and 36 phones. We can get that down to 1 to 2. And 9 kilometers to 300 meters. We want to do 9,000 kilometers instead of converting 300 meters to 0.3 kilometers. And we can get that down to, what would that be? 30 meters to 1 meter, or just 30 to 1. This is our last question. The recipe for a mocktail requires pineapple juice and orange juice in the ratio 2 to 4. How much pineapple juice is required to make 1.5 liters of mocktail? So there are 6 parts, and 2 of those parts, so we'll do 1.5 liters divided by the 6 parts. So 1 part is going to be 250 mils. And 2 of those parts are pineapple juice, so times that by 2, there are 500 mils of pineapple juice. The recipe then suggests adding lemonade to the mocktail. If the ratio of lemonade to pineapple juice is 1 to 4, how much lemonade has been added? So now this is a 5-part ratio. So we'll divide 500 by 5, which is 100 mils per part, which means that there is now 100 mils of lemonade. Alrighty, so how do we ace ratios and rates, or rates and ratios? Remember your conversion. So if you're getting larger, like you're going from meters to kilometers or grams to kilograms, you divide. If you're getting smaller, so you're going from kilograms to grams or liters to milliliters, you multiply. Also, use your common sense. If your number looks way too big or way too small, like I said with credit cards, it probably is. Just try it again. Make sure that you didn't stuff up somewhere. And remember that when you're trying to convert to a larger form of measurement, you need to divide, as I just said. But people always assume multiplying makes it bigger. Just try and drill that into your head. Remember the important how important order is in ratios. Even if it looks like all the bigger parts at the front, that doesn't mean it's wrong. It just means keep an eye on where the parts in your ratio have ended up. Alrighty, so we're going to finish up in a few minutes, but as I said, I'm going to answer 3 questions that I always get, and I also want to talk about what's on the screen really briefly. So approaching year 12, my biggest step to you in the next couple of months is accepting that it will be stressful, and it is hard, and it's going to suck at some points, but it does not have to dominate your life, and if you're lucky like me, it might be one of the best years of your life, despite it simultaneously being the worst. It's a paradox like that. One of the most important things is trying your very best to stay up to date in your maths class. And if you don't, learn to prioritize. So what I would do is if I was falling behind because I was doing something else or I was out of school that day, I would try and cut my homework in half, or I would try and skip the first third by only attempting the harder questions that are usually at the back of the exercise. So you can usually tell the first ones are more like practicing conversions or doing easy tax questions, but the back ones are going to be way harder. Try and prioritize by cutting out those first few questions. The other thing that I have on here is about planning your revision weeks out from the exam. So let's say that this is like your trial exam here. Hopefully it would be more, but let's say like borderline 1 week out, you're able to do just full exam conditions. 2 weeks out, you're doing it like timed with a few notes. 3 weeks out, you can do it untimed with your notes out. And 4 weeks out, you can work on finalizing those notes. The most important thing you can do is the green section. People who do this section and people who never do it are the difference between like an 80 and a 98 ATAR. Like that is actually the difference, is are you practicing in full exam conditions? Because full exam conditions is what matters, right? If you can write an essay in 3 hours, that's great, but you need to be able to do it in 40 minutes in modern history. So it's about, can I do what I'm able to provide outside of the exam in the exam? That is what will determine where you fall on ATAR release day. The 3 questions that I get at the end of every lecture are, where do I find practice papers? What do I do if I still don't understand something? And what do I do if I procrastinate? I'm going to walk through each of those 3 questions now. Firstly, where do I find practice papers? Okay. On the internet, you can go to NESA and do all of their practice papers. You can use ATAR Notes Plus and ATAR Notes Shoot Smart in general, all of our resources. We have paid and unpaid. ACE HSC has a bunch of past papers, and then the internet in general. Try Googling around. Also ask your school and your teachers if they have past papers. They might store them in the library. Your teacher might have copies, because a lot of them you have to pay for. That is my best tip with that. But again, we have a bunch on ATAR Notes Plus and in our database as well if you want to check them out. And as tutors, I'm always providing like millions of past papers. Second question, what do I do if I still don't understand something and I'm struggling to learn it and I just feel like it's never going to click? The first question I would have is like, are you trying to learn the same thing the same way? Sometimes you're trying to learn something via like letters and words, but maybe it needs to be learned visually. Maybe with working with time questions, you need to try and do them visually instead of word-based. Or maybe with networks questions, it's too visual and you need to kind of cut back and just focus on the words and the letters. So are you learning it one way, and should you try and change the way you're learning it? And have you exhausted every resource that you have? Your teacher, your peers, other teachers at the school, an older sibling, a tutor, YouTube videos, ATAR Notes books, whatever it is, have you gone to every single resource? Because I guarantee there is a resource that can help you learn it better than you've already tried. The last question I always get is, what do I do about procrastination? And I am the biggest procrastinator. I procrastinate everything in life, but I've never missed an exam. I've never missed a due date. I've never missed an assignment. I've never missed anything, right? I am procrastinate, but I'm very organized. And so I never miss anything. And I do quite well on most things that I hand in. I've still got a distinction average at uni. I managed to get a 95.6. I'm not failing, right? My biggest tip is some people are actually just being a little bit lazy sometimes, and you aren't procrastinating. You're just kind of like, maybe you could work a bit better. Most people, you are a procrastinator. And for me, the best thing I did was accept that that was how I worked and use it to my advantage. So now I understand that I'm a procrastinator, but I use it as my way to learn, if that makes sense. So the first thing I do is I don't like lie to myself anymore. I don't pretend that I'm going to wake up and start work at 10 a.m. in the morning. I won't. I usually start on a weekend at maybe like 2 or 3 in the afternoon at my very best. Usually I start at like 6 o'clock at night. So I stopped lying to myself and wasting the day, and I started making plans for things, right? I'll go to breakfast. I'll hang out with my friends during the day. I'll go to the beach and I'll do my work afterwards. Or I make plans in the evening so that I have to do the work during the day. That's been a real game changer for me. The next thing is that it doesn't mean that you're a bad worker, or it doesn't mean that you're bad at studying, right? Like, I was able to get high marks than a lot of people who had way more structure in their study and would start at 8 a.m. on a Saturday, right? It doesn't mean that your work is worthless because you're doing it at a different time, or you're doing it later, or you're doing it closer to a due date. I work well under pressure. I like having pressure and I like having deadlines. That's how I work best. It's not the way everyone works best, but if you're like me, accept that that's the way you work best and use it to your advantage. Another big game changer for me is writing things out in really, really small chunks. So when I have an assignment or an exam, my to-do list will be like create exam document, print notification, print, like I said earlier, and I make it so minute that I know I'm succeeding when I am ticking off like 10, 15 things on my to-do list. Now, it's not like type 10 words, but it will be like write intro, research that one idea, or read cases, or whatever it is. And it helps me actually achieve things on a to-do list rather than just writing down do assignment, because that's so daunting. Like, you sit down, you're like, oh my God, I have to do my assignment. No, break it down and schedule it out the best you can. I actually do schedule work for myself. I find that I like stick to it fairly well. But making plans that are in the way of your studying, that you have to study beforehand, and breaking the work down into chunks are two big game changers. Another thing is this app Forest. I'm a big distraction person, so my phone, I find it super distracting. My laptop. What I do is actually keep a list next to me, and whenever I think of something I want to like Google or do, I'm like, okay, so I really need to like do my washing. I write down like do washing. Or if I'm like, I really want to Google that like one thing I saw on TV, I write it down, and then I can go through that list later, but I don't have to like keep Googling that like actor that I thought about from like 2011 that I want to Google like in the middle of my study. No, I write it down, come back to it. Forest is amazing. Basically, you like plant a little like fake tree and it starts growing. We'll cancel that. And what happens is if you go on your phone or you do anything else, it dies. And so I've unlocked all of these beautiful little trees in here. And I'll show you, I guess I can show you my forest from high school. Yeah, that was my little forest I grew in year 12, and I've used it every year of uni since. So, for example, last year I planted 80 trees and I focused for 41 hours. My HSC year, I got 50 hours and I planted 99 trees. So I find that super useful so that I can't get on my phone, because I like can't kill the tree, guys. Like, if you kill it, it's just like dead in your forest, and it's like, I don't want dead trees. So it works on me. But there's so many ways you can like lock down your browser, lock down your phone, but that one works for me. I hope that I've answered most of the questions that students usually have. If I haven't, I'm also in the chat right now answering your questions, so continue to ask away. But I am going to wrap up here with you guys. It won't close. Like, you can keep talking in the chat. It's all good. But thank you so much for joining me today. I hope that you found this helpful or beneficial or supportive in some way or another. I do my best to kind of give you different parts of the content and make sure I'm giving you tips that I think are helpful, but every student's different, and I just hope it was helpful to you in some regard. You are going to smash it. Remember, our lectures are quarterly, so we're back here in April with our next round of lectures, and then again in July and September. So I hope to see you guys then. All the very best with your first term back for the year and your second term of year 12. You're so close to finishing. It will literally go like that. So have fun, enjoy the time with your friends, and hopefully I'll see you back in April. Bye, guys. You're going to smash it. Good luck.